Good morning, everyone. Thank you for attending. Chris Van Tine, Chief Technologist for the West Coast at Red Hat, and I've been at Red Hat for about 14 years. And today I'm going to talk about continuous security with Kubernetes. But first off, talk about some of the drivers. Andy Grove talked about how only the paranoid survive, and it's not about security, but about strategic inflection points in a company's lifetime. There are points when there's massive amounts of disruption, maybe it's new technology, new competition, and the company has to decide, do they stay the course or do they pivot and change direction? And how do they make that decision, right? By having the pulse on the market and being able to move and react quickly. And so there's a lot of pressure on IT today to do exactly that. Pretty much every industry you look at, there's massive amounts of disruption. The disruptors are disrupting the incumbents, and they're leveraging software and they're leveraging automation to do that. Take a look at the automobile industry. They have this vision of the autonomous vehicle someday. And certainly we're incrementally getting there by automating more and more. And think about how the automobile has changed. Just look at Tesla leveraging software for automating the production of these vehicles in their factories. But for the first time also, the vehicle is very different after it leaves that factory. Right? They're able to get over-the-wire updates, providing new capabilities. Maybe it's new software updates to improve the 0 to 60 time, battery efficiency, or applications. And when they have autonomous driving capability, the ability to deliver new improvements or new security updates. It's almost a must-have in order to make this a possibility. If you take a look at what the strategic differentiator has been for companies over time, Intel, certainly the fab, has been their strategic differentiator, just like the automobile factory for Tesla, but also for internet companies, the software data center, their automated factory has been a differentiator for them. They're able to continuously build and deliver new innovation for the business rapidly. And it's not just about having the website or mobile application for these companies inside that factory, right? They're able to speed up innovation and they're able to shorten the feedback loop to deliver that new capability. And how are they doing that? They're empowering their organization, right? They're embracing the concept of lowering the decision-making and opening up decision-making to those who are on the front lines. And they're empowering them to do exactly that, enabling them with tooling and automation. They're able to deliver new capabilities to the marketplace for their business in a matter of days or weeks rather than months or years. And they're able to shorten that feedback loop because they have their pulse on the market. Right? Think about Uber. They're able to dynamically adjust pricing and drive more drivers or more riders to the marketplace by bringing the price up or down in real time. And they're able to experiment, try out new capabilities in a certain geography and get feedback right away. And if it's successful, then to continue that rollout. And so there's a lot of pressure on IT to do exactly that for their business, is to accelerate innovation and do that in a matter of weeks or days. And how they're doing that is really adopting this software factory that the early internet leaders have done already. And it consists of a cultural change, process automation, and technology. From a cultural perspective, being collaborative, transparent, and open, very similar to an open source community. And that's to really drive innovation at a much rapid pace. Also, implementing automation around process. Basically, being able to continuously deliver those new capabilities from dev, test into production, and leveraging new cloud native or open source based solutions to make that happen. And so the technology shift to a microservice DevOps cloud infrastructure is driving this rapid innovation for these companies. And that's why you're seeing the embracement of these shifts in IT. And certainly containers are a big part of that. But what about security? Right, we're seeing a shift to distributed application architectures as you move to a microservice. No longer is the application all sitting on a single server, right? So what are the security implications? How do I address those? Also, we're seeing a shift to hybrid or multi-cloud environments. Maybe you have dev tests in public cloud in your production on a private data center, right? No longer do I have all my applications or my network self-contained in my own data center. And likewise, I can no longer assume I have full control over a single server. It's shared multi-tenancy, whether it's on a public cloud or even in my own data center in a containerized or virtual environment. And so securing this enterprise has been becoming a lot more challenging and harder, and I can't rely simply and hide behind the network firewall any longer. You know, we're seeing influx of threats and attacks on infrastructure, many for geopolitical reasons or competitive reasons. Also, this dissolving security perimeter as a result of these multi and hybrid cloud environments, and the movement towards more and more software-defined infrastructure, whether it's storage, networking, or compute, and the shift to adopting either public or private cloud and expanding my infrastructure well beyond just my own self-managed data center, as well as employees bringing their own devices and applications into their networks. And so that's why you're seeing the shift to DevSecOps, right? DevSecOps is all about a cultural and process and technology shift, but it's about integrating security into the culture, right? Security first, from the business demanding that it's part of the requirements to the developers implementing it early and often in their development and testing environments before it's rolled out into production. It should be a separate nature and not be viewed as a bottleneck in incumbing and reducing innovation. And so in order to do that, really need to automate processes and adopt, leverage tooling to help do that as well. And so this shift to DevSecOps is all about security automation, process optimization, and continuous security improvement, right? And so with the shift to containers to enable this, we're seeing, containerized microservices. And why is that happening is a container allows you to build your application once and then deploy anywhere, right? It abstracts the developer from the target infrastructure. No longer as a developer do I need to know this application is going to reside on Amazon or in VMware or on a physical server, right? I can just package it in a container, and that can be deployed across any of these environments, so it doesn't affect the package delivery format. And that is all made possible because of the Open Container Initiative, which is a standard to standardize on the image format of the container, as well as the runtime and the distribution and sharing of these via a registry. But managing containers at scale requires an orchestration layer, right? And that's where you see the adoption of Kubernetes across the industry, really to kind of enable a automated software factory for continuous building and continuous delivery of applications, right? It makes it very scalable across multiple data centers, multiple availability zones. It also allows you to increase your velocity of the delivery of the applications into production. It also is self-healing and self-managing, so it provides excellent resiliency for your application and allows you to efficiently use your resources effectively. And more folks are seeing this as really a platform from a security perspective. Now I can have the same security process and tooling across any provider because Kubernetes can be deployed across a physical, virtual, private, or public cloud infrastructure. And so today, I'm going to talk about some of the best practices around security start out with automation, images, builds, scanning, and deployment strategies. So first off, if you haven't used Kubernetes, some of the key concepts in what it does in terms of automating your IT infrastructures First off, it allows you to orchestrate the deployment of your application in a containerized cluster. It does this by allowing you to package your application in a container, store that image into a registry, and then it will provision your infrastructure across a cluster of nodes. In what's called a pod, it'll deploy one or more container instances. It'll set up the networking automatically for you. It'll route traffic and load balance across multiple instances, for example, of your web service for you. And it'll also enable you to route outbound traffic or outside traffic into your cluster. And it does this in a declarative way. So I can just state that my application, for instance, is 2 web servers and a single application server, and it'll go ahead and deploy that out to your infrastructure and ensure it's always in that state. It also automates the health checks for this infrastructure. So it'll monitor and detect if there's a failure of one of your container instances and automatically schedule a replacement for that across your infrastructure. And then thirdly, it does auto scaling. So enabling scalability by monitoring and detecting the load on your hardware or the traffic coming into a particular service and able to scale that up so that it can fulfill all the requests. In this case, moving from a 1 instance application server to a 2 instance. So in terms of best practices around security for images, first off, the basic flow for containers is to build, ship, and run, right? So you have your build environment where you're specifying a build file for how to create your container that is building into a container image. That image can then be shared across environments, dev, test, production, physical, virtual, private, public cloud, as is. So as a developer, I only have to build it once, and I share it via the registry. I then can run it in a standardized way across all those infrastructures with the standardized container runtime. And when I instantiate that, that creates a container instance. The container image itself, if I'm moving from a traditional, maybe virtual machine or physical infrastructure, typically deploying and delivering a jar file from dev into test. In a container world, you're going to be delivering a container image. Right? That container image has multiple layers. You have the OS dependencies that get pulled in. You also have the language runtime dependencies and the application itself, the Java code. Right? It doesn't have a Linux kernel. It's not a full-blown operating system. It's just those components that the application needs. And so the advantage of this is it then prepares you to have multi-tenancy capabilities in your infrastructure. So now I can have one version of my application sitting side by side with another version of the application, all with different maybe OS or application runtime dependencies, right? But it doesn't matter because everything I need to run that application is contained within that image. So one of the best practices with containers is to make sure you treat them as immutable. Right? What does that mean? That means the container image should only contain your code, the application dependencies, and the OS dependencies. The configuration and the data should be separated out of the container image. This makes it stateless and allows you to really scale up and then also have a reduced footprint from a security perspective. The configurations in a Kubernetes environment can be stored in what's called a config map. Right? This is a resource that's available in Kubernetes. It's stored centrally in the Kubernetes cluster in the etcd data store. Right? This is a key value map. You basically define the value, right? And you store it in the configuration map in your Kubernetes environment, extracted out of your container image. Then it can be deployed into the container image when it's launched at runtime in the cluster, in the container instance, as an environment variable or as a file in that container image, or a container instance. The data can be extracted as well and stored on persistent storage right? So when you launch a container instance, it can mount any traditional storage into the cluster or the container instance, or you could access it remotely via a remote data store, right? So maybe it's a cloud database service. So let's go through an example. Typically, I have maybe an application server that has some XML configuration. Maybe it's my JBoss middleware Java server. There's the XML file. I store that XML configuration file into Git. I version control it. And now I want to launch an instance of JBoss in my Kubernetes cluster. I can do that by specifying a config map which imports the entire XML file for my JBoss configuration. Then when I deploy my JBoss image, it will create a JBoss instance and define the config map in that instance as a particular file in a specified location. If I have confidential information such as username, password, or some keys, I could also store those in a similar way, but instead of it in a config map, it's called a secret. It also is stored in the etcd shared data store in the Kubernetes cluster, but it's encrypted for me, so I don't have to worry about exposing that. Also, a best practice around container images is to make sure you're signing those images so you know that's coming from a trusted source. How about automating the build process? So you want to integrate this into your CI/CD pipeline, and you want to make sure that it's an automated process. I'm coming from a world where I have my sysadmins creating the base image for the OS. I have my middleware team creating the middleware layer, and then I have my developers contributing the code. Today, they're all using different tools and different syntax to make that happen. I have the kickstart file for the OS. Maybe I have a zip file or tarball for my middleware layer, and then I have the jar file for the developers. So it's very hard to collaborate together, but with the container environment, everybody can specify their layer in the build file, right? So if I'm an application developer, I can just select a pre-built container image that has the components I need, the JBoss and the Linux operating system. And then the middleware team, they can just specify and build upon a particular operating system. And then the admins can just maintain the OS image, right? So I, as a developer, don't have to worry about security updates to the OS or application layer because the other teams are maintaining that for me. I can also automate this once it's in production. I have my application that's built upon the middleware and the OS layers, right? If it detects a change to those layers that my application depends on, I could monitor, for instance, the registry to see if there was an update to the image for JBoss or the Linux OS, and then trigger my continuous integration, continuous build process, and then produce a new version with those new security updates. Okay? And one of the best practices that you want to follow also in a container environment is to make sure that your builds are reproducible. So how would I go about do this? Well, one is you have your source code, for instance, in your repository, version 3.1 in this example. And then to build that source code, I want to leverage a containerized build image. Right? This containerized build image is a lightweight instance that just has my build tools. Right? And then I use that, it's version controlled, to build my software. And that will produce another image which contains that built application and just its immediate dependencies. Right? So I don't have the build environment, I don't have those intermediate files, it's very lightweight, and now I have a record of what version of the build environment was used to create that particular container image. So I can go back in 6, 12, 18 months and reproduce that image. So, reproducible builds. How does the build look like in a CI/CD pipeline? Well, here's an example CI/CD flow. You have your dev, UAT, and production environments, all built out virtually in your Kubernetes cluster. And as a developer, I'm going to submit my build file, my application code, and then trigger this build process. The build process would pull down the build image, build the application, create a container image, put that into a registry, built it once, and then it can be propagated to my dev, test, and my production environments. I no longer have to rebuild or reconfigure as I move into a new environment. Right? So build once, deploy anywhere. Now, another best practice is around container scanning. What inside this container matters. If you take a look, I have some example container images from left to right. I have my Java, or my C, Java, Node.js, Perl PHP, and it shows you, as you build these images, what dependencies is it pulling in. For example, in the second column, the Java application is pulling in the JRE, it's pulling in glibc, and the little triangle shows you how many security notifications have been issued for those components. The JRE has well over 66 security notifications. So the key here is, not only do I need to know that it's coming from a trusted source, these images that I'm pulling into my environment, I need a process to continually be scanning and checking to see if there are new vulnerabilities once I'm using these images in my environment. And so one of the best practices is setting up a private registry in your data center or in your infrastructure that you can control and manage and have an audit trail for who's pushing images to the registry, having a historical view and access to older versions in case you need them down the road. And then secondly, you want to integrate some sort of scanning into your CI process. So you may add a phase. This is a Jenkins pipeline, a security phase, which triggers a scan anytime you build a container image. You can leverage a variety of third-party tools out there in the marketplace. There's also an open source tool called OpenSCAP, which allows you to scan your images for security policy. It also allows you to scan them for security vulnerabilities, right? And produce a remediation script to rectify the issues in the container instance or image. It also generates reports as well, so you have an audit trail and you can show to the auditors. Now, once I deploy that out into my environment, I need to be able to update those containers in my production environment. Traditionally, in a virtual or physical world, I just go and patch, for instance, if there's a security issue directly on that server. Why do I do that today? It's because it takes weeks or months to deploy a new version. Well, if you have an automated software factory, you can deploy new container instances in a matter of minutes. And so in a container world using Kubernetes, instead of patching your production servers, typically you would go back to your development environment and create version N+1 that addresses that security issue, push it through the entire pipeline, including the security scanning. And so I need a way then to be able to automatically deploy these updates at scale. And so within Kubernetes, there's some deployment strategies built in, such as recreate, rolling updates, blue-green deployment, as well as a canary to enable A/B testing. So let's walk through those. First off, recreate with downtime. So this is the simplest. This is when I have version 1 out into my production environment and want to upgrade to version 1.2 because there's a security issue. So with recreate, I just bring down the entire application in the cluster, and then I'd redeploy the new version, right? The downside to this is that there's downtime. I had to bring down the cluster, so it's not for every service I have out there. But it was really simple. I didn't have to collaborate with my developers and have to have backward compatibility. Next, I have rolling updates. So this is when I want to gradually roll it out. Maybe I want to get some feedback. Is this security update addressing the problem I intended it to? And so I could have version 1 out there and then gradually roll out version 1.2. Right? I may stop it midway because I got some data back, and I may update it to version 1.3 to address those issues, and then revert back and continue forward as well. And so the rolling update is 0 downtime, so it overcomes that downtime requirement of the recreate. But I'm going to have 2 versions at once out in production. So I need to make sure that my application and the database are able to handle that as well. So I need to collaborate with my developers, need to be aware that there are potentially 2 versions out there. Another option, probably the more common one, is a blue-green deployment. This is where you have the blue environment with the current version. You know, there's a security issue. I want to develop a new version, 1.2 or version 2, and I'm going to deploy that in a logically separated environment called green. Right? Same physical infrastructure. In Kubernetes, it allows me to redirect all the traffic and route it through the router or through the service to the new version, my green environment. If there's an issue with that, I could actually revert it back as well. And I could also, right there, back to version 1. And so the nice thing with this is I didn't have any downtime. The difference with this and a rolling update is I also didn't change my existing environment. Right? So if I need to revert back, I have a high degree of confidence that the application is continue to function, or the environment will continue to function exactly as it did. So lower risk. Also, you know, how do I enable my developers to experiment, try things out? That's a big part of microservices. And if I have 2 versions, A and B, I want to be able to experiment and try that out in Kubernetes. So version B here has a different recommendation engine. And I want to see how that works out with real-world traffic. And so what I can do is I have version A out on the left side. I have a 25% conversion rate, and I'm using the Kubernetes labels to direct traffic from that service to those pods. And then I can update the selector to include a version B so that 25% of my traffic gets routed to version B. So I'm getting some real-world results, and on the monitor what the conversion rate is, it was 30%, so it actually improved. And because I saw that improvement, I can go all in on that new version. Right? And so I just updated my Kubernetes selector for that service, and all the traffic is being routed. Right? Also, one of the things, if I'm dealing with security issues, I want to be able to quickly switch from one service to another as I move from dev to production. So you can do that in Kubernetes. Here I have my development and my production services. On the left and right, different IP addresses. This might be hosted on a public cloud service, and I want to be able to access these from my application. And so on the left, I have my web app, and it needs to access my external Mongo data service. And so what I can do is in Kubernetes, I can create an endpoint called the database, which is a cluster IP, point it to my red database. And so instead of actually running that database service in the cluster, it's outside the cluster, but I can still have my application access it, and I can hard code the connection string MongoDB/Mongo in the container instance, so I don't have to change that and edit it as I switch from the red to the blue database. So this might be switching the database as you move a new security update from dev test into production. Right, so that's a cluster IP service within Kubernetes with a supported by an endpoint, which just has its IP address mapped to it. And then lastly, database migrations. So as you deploy new security updates, you may also need to upgrade the database, right? So how do you coordinate that if the database is running within the Kubernetes cluster? Well, you can use a schema version control tool such as Flyway, which is an open source solution. And this allows you to have different versions of the database, dev, test, and production, version 3 through 1. And maybe the security update in version 2, I want to move that into production. What you do is you maintain a schema update SQL script with Flyway. You store that migration script, version control it in your source code repository, and then you build a container image with the Flyway solution and the migration script. This allows you to then create a container image, and then within your Kubernetes cluster, what you can do is you have your database, version 1. I need to update the schema to address a security issue. So I'm going to go ahead and schedule what's called a Kubernetes job, which will instantiate the Flyway container image that I just created with the migration script. And it will run one time, connect to the Postgres database via JDBC, apply the migration script to it, updating the schema, version controlling that schema, and now I've upgraded that database to version 2. Right, so this is how I coordinate my application updates with my database updates. I typically would do this first, and then now I can deploy version 2 of my application, which addresses that security issue. Okay. And then lastly, at the infrastructure level, from a security perspective, Linux provides some key security capabilities such as cgroups, namespace, SELinux, seccomp, and read-only mounts, which allow you to harden your container host, right, enabling you to have multi-tenancy. And a little short on time today, but as you look forward to your Kubernetes cluster, some of the new concepts, new projects that are being developed to augment the capabilities. One is the KubeVirt project. So that's going to allow you to manage not only containers, but also virtual machines. And then from a security perspective, Operators is another project which allows you to automate the management of your services so that you have true automation in terms of the deployment of your custom applications, consistency, and the rolling out of security updates as well. So think of this of getting all those nice capabilities that public cloud service has and bringing those runbooks and converting them into an automated operation for your Kubernetes cluster. Also, serverless. Knative is actively under development to bring serverless on top of Kubernetes, and then the service mesh, which has some good additional security capabilities in terms of managing mutual TLS for service-to-service communication as well. So I want to thank you for attending today's session. Here's my contact info. I'll be around later to answer any questions, and I want to thank you so much for attending. Thanks.